Good morning. It's indeed a great privilege and honor to be present here on this momentous day where, as already Jagdish pointed out, exactly 2 years back on this day, evening 6 o'clock, 6:04, Pragyan rover and Vikram lander touched the surface of the moon. In memory of that, the Government of India has announced this as a National Space Day. And today I have the privilege of talking to you about that in the presence of respected Swami Nityanand Ji Maharaj and all the monks of Ramakrishna Mission and many of you who are students and also others. If you look at how India started this journey of going to space and how it has made a difference to us, I would like to bring to your attention that India got its independence in the year 1947. And humanity got a new capability, a new technological tool, and one country went ahead of others. And it was in the year 1957. Any of you can tell which country it was and what happened in 1957? Want to try? Okay, I'll tell you. Sputnik was launched by Russians in the year 1957. And for the first time, humanity, of course in the recent millennia you can say, got an opportunity to put an object beyond Earth, make it go around Earth. And 1957 is just 10 years into independence. And after many hundreds or thousands of years of external rule, Indian administration was struggling to provide food, shelter, and education to its citizens. At that time, if somebody were to look at going beyond Earth and going into space, how can it make a difference to the lives of Indians? Probably many would have their questions. But then we had great visionary scientists like Dr. Sarabhai, Homi Bhabha, who were looking at how this new technological capability of putting an object in space can make a difference to the lives and the growth of the country. And what Dr. Sarabhai had realized is going to space can make a difference simply because Arthur Clarke had already shown that if you can put a satellite at the height of 36,000 kilometers, why 36,000 kilometers? Because you are familiar that every object which is orbiting Earth, depending on its altitude, takes some finite time to complete the orbit. For example, Moon takes a month to go around Earth, but Moon is at a distance of 384,000 kilometers when it is closest. The near Earth orbits, the objects take between 90 to 100 minutes. That means between closer to Earth to 380,000 kilometers, there must be one place where if you put a satellite, it will take exactly 24 hours to go around Earth. Now what has this 24 hours got to do? Because Earth takes that much time to rotate about its own axis. And if you can put another object going around Earth, taking exactly same time, you will end up with a relative velocity which is zero. Many times when you are traveling in trains, an adjacent train traveling at the same speed appears to be stationary to you. Same way, this 36,000 kilometer altitude, if you put a satellite in equatorial orbit, that satellite looks stationary to an observer on Earth. And why it will be useful? When you want to see farther and farther, what do? You climb to higher and higher points. You go on top of a tree, mountain, or a high tower. So same way, if you go to the height of 36,000 kilometers, not only 1/3 of the Earth is visible, it is visible continuously. So you can do what is called line of sight communication. That means you are able to see each other and do communication. So Dr. Sarabhai was aware that if a satellite is put at this altitude, it can help us do communication. So what was done? He convinced Americans that one of the most advanced technology satellites they were building at that time, he asked them, why don't you lend this satellite to us for 1 year? We will use it and demonstrate in our country how we can bring in communication and broadcasting revolution. So, Americans who were building a new technology satellite at that time, that satellite had a life of only 2 years. But in spite of that, they were ready to give for 1 year it to us because they realized that it will serve as a great demonstrator of a capability of a satellite up in orbit. And what happened in 1975, exactly 50 years ago, India conducted the world's largest socio-technological experiment. It is called SITE, Satellite Instructional Television Experiment. What was done in that is, you can imagine in the 70s, etc., India was struggling to provide its citizens various capabilities. And if you had to reach out to everybody and inform everybody of what is happening, we were about 36 crore people at that point. How to reach information to everybody was the challenge. So what Dr. Sarabhai finally could do was, today you are familiar with a small quarter-meter antenna on your rooftop and a set-top box on the table. You can see broadcasting on your television. This is called direct-to-home television. 50 years back, India demonstrated to the world this concept in what is called as direct-to-community system, satellite instructional television experiment. By borrowing an advanced satellite from America, and in 2,400 villages in our country, 6 remote states, in those places, ISRO set up half a rack height of electronics equipment called the front-end hardware with a 10-foot diameter antenna. Today it's a quarter meter, just 250 millimeters. That time it was 10 foot. With that antenna on the ground and a huge rack of electronics, front-end hardware, and all this was realized in the country, black and white television of ECIL and all these electronics built in India. ISRO demonstrated to the government that you can reach out to large part of India if you can make use of this technology. So for 1 year, this experiment was conducted and it was considered as the world's largest socio-technological experiment, a technological experiment which demonstrated how communication can be brought into reality in developing countries. In fact, for that particular program, world recognized India and gave an award for that experiment also. But that apart, Dr. Sarabhai's ability to convince Americans that we can make use of this technology in a better way. At that time, there was also a competition. India was competing with Brazil, but India could convince Americans that between Brazil and India, if you give this satellite to India, they'll make better use of it, because Sarabhai had also made sure that the experiments preparing for use of this satellite for 1 year was done much earlier. And with Krishi Darshan program in Delhi's TV, it was trying to show how the program can be brought to the people. In fact, if you look at what was the alternative mechanism available to the country at that point of time, many of you have seen when you are traveling these microwave towers, and every kilometer, if you can put one tower, India is 3.25 million square kilometer wide. So how many towers would have been needed, you know? And to go to each of those places, establish those towers, would have been the alternate way of reaching out to the entire population. So obviously, the government saw the advantage. You can also see the powers that be, you go and tell them that what you are speaking can be heard all over the country at the same time. Do you think you need more convincing the government for accepting a project? This too in the year 1970s, etc. So when India demonstrated this, it became clear to the government that space technology is the way to go, and then using that, in fact, this year, like I said, we are completing on August 1st 50 years of completion of this experiment. And just as though you can see what happened in this, India had to depend on an advanced technology component from America to demonstrate this capability. But on 30th July of this year, another very big event happened. I don't know how many of you have noticed it. A satellite called NISR, NASA ISRO Synthetic Aperture Radar Mission. This is a satellite which is built in collaboration between India and USA, ISRO and NASA. A satellite was launched by India from Sriharikota and has been put into the orbit, and it carries a 12-meter diameter antenna which gets unfurled when it goes into space. In fact, this satellite is capable of providing very useful information about the Earth's health, whether it is surface deformation, flooding, water, biomass, a host of them. But the point of my telling is, this particular satellite was launched by us on the 30th of July, and at this time, India was an equal partner with America for bringing in one of the most advanced technology satellite providing Earth observation capability, and the data from this is going to be available for the entire humanity. So in 50 years, you can see India moved from depending on an American satellite to be competing with them and actually collaborating with them. Now I'll tell you how this whole story evolved and how we developed. When Dr. Sarabhai was starting this activity, in the year, like I said, 1957 was the first object put into space by Russia. And you also know, Russia went ahead, they put their first dog into space, man into space, woman into space, but then Americans were feeling left behind. They said, how can Russia go ahead of us and outbeat us in all this? So they said, we will put man on moon. So in 1969, they succeeded in putting man on moon. And I still remember, I was a student of the National College, which is very close to this place. And in that afternoon, we are listening to a transistor radio news of Neil Armstrong landing on the moon. So America was trying to compete with Russia and demonstrate who is more powerful, etc. And while this was going on between two military powers, what India was trying to do was make use of this technology for societal development. Apart from this communication, how did it all start? In 1963, India launched its first sounding rocket from Thumba Equatorial Rocket Launching Site. And even for doing this, many of you are familiar with what is called as do-it-yourself kits. You can assemble that, and then based on that assembly, you can learn the tricks of the trade. So Dr. Sarabhai had to convince people across the globe that we needed to put some of these rocket technology in the country. So he convinced his friends across America, Russia, France and Germany, and also United Nations, telling them that the space technology is going to be very useful for the humanity, and not only these superpowers, others also should learn how to do it. In India, we have a unique point called geomagnetic equator, which is very close to Thumba. So he convinced his friends across the globe, telling them, if we conduct upper atmospheric research at this location, the information collected will be very beneficial to the scientific world. So with that in mind, he could get sounding rockets in the form of kits, got it assembled in Thumba. And probably many of you have seen in the pictures, there is a church which is shown. Today that church has become a museum. And in that church, the first sounding rocket got assembled. And even for doing this work, Actually, Dr. Sarabhai had to convince the fishermen in the beach there that you vacate this place, allow us to conduct these experiments of sounding rockets, one day the country will benefit. And even for that, he had to take the help of the priest of that church, Bernard Pereira, and to convince the fishermen. And with successfully convincing them, the Indian activity of sounding rockets started in the year 1961 in November. And you can see within 1963, sorry, within 6 years of first object going into space, India was doing experiments. And then, as though what had been promised to the fishermen that one day the country will benefit, what India was able to do is, from 1999 onwards, using satellites orbiting in space, looking at the color of the ocean. See, like when we see in color, we see in 3 RGB, you are familiar with primary colors. So if you look at any object in many different colors, you can get a lot more information about that. So India put a satellite into orbit. By looking at the color of the ocean in 8 different wavelengths, it was possible to find out where is the chlorophyll, and through the chlorophyll, the algae and the food chain of the fish. And from that, it was possible to tell where exactly in the ocean, if the fisherman goes, he is assured of a fish catch. This is called prospective fishing zone identification. And this information, India started giving to its fishermen. You also know we have 11,500 kilometer long coastline. Lakhs of fishermen depend on for their livelihood on the fish catch. So what India started doing, 1999, a center in Hyderabad called Indian National Center for Ocean Information System started providing this information of where to go for fishing to the fishermen, at that time through pagers and electronic news boards. This activity alone saves to the country between 10 to 15,000 crores a year. You may wonder how. Because now the fisherman is assured of a catch and he knows where to go exactly. But by that, he is saving the petrol and diesel he spends and also the time it takes for him to search. Through this, India saves almost this kind of money year after year. Recently, with our own navigation satellite, which you also know is a very different way of doing navigation activity, whereas America, Russia, China, as well as Europe built 24 to 32 satellite constellation, India came up with only 7 satellite constellation to provide specific information through a gadget in your hand to identify where you are, that means locate yourself, called GPS or positioning system. So India came up with this 7 satellite constellation, and what is done today is a small battery operated gadget can be fitted in the boat of the fisherman. This gadget communicates with the NAVIC satellite, and an app on that mobile, in the hands of the fisherman. You can easily imagine your mobile when you go many hundreds of meters away from a tower, it will not be able to communicate. See, in the ocean, if the fisherman gets few kilometers into the ocean, no terrestrial tower can reach him. But this gadget, along with his mobile in his hands, is able to communicate with the satellite, and a video compass shown on the mobile points to the fisherman where he has to go for fishing. Not only that, it gives him an alert in his mother tongue if the weather is not going to be favorable, very heavy rains, winds, etc. if it is there, or sea state roughness is going to be unbearable. The mobile gives in the mother tongue of the fisherman an alert saying it is time for you to go back and save yourself. Similarly, many times you see in the papers, our neighboring countries capture the fishermen because they are wading into their waters. Even for this, the fisherman is alerted, telling them, using what is called as geo-boundary or geo-fencing, it gives them an alert, says, you are approaching international waters, be careful. So what is the example you are seeing here? A person who does not know reading or writing is making use of the most advanced technology of a rocket putting a satellite into orbit and payloads on the satellite providing information through a mobile to a person who doesn't know how to read or write, but then can listen and see and make use of it for his livelihood. This is another very interesting example of how space technology made a difference to the lives in the country. Another very important aspect at that time was, you have heard, super cyclones used to result in tens of thousands of lives being lost because this natural disaster, when it occurs, where it occurs, was not known in advance. But today, by looking at Earth from space, from geostationary satellites, you can take repeated pictures every few minutes or few hours, and then by making use of the cloud motion, you take cloud pictures over India, and by looking at multiple frames, you can tell what is the cloud motion, what is wind velocity, what is temperature, a host of parameters you can measure, and these parameters can be provided to the model, weather forecasting models. And today, you know that when super cyclones hit the country, our disaster relief agencies are able to evacuate them and save the lives of tens of thousands of people, and these big natural disasters are avoided for loss of life. But anyway, property damage still happens, but then at least lives you are saving. So you can see what Dr. Sarabhai had in mind was, how can we make use of the space technology for providing solutions to the problems of the country. In late 60s onwards, they started working on how to reach information to everybody, broadcasting, communication, and weather monitoring. And not only weather monitoring, I'll touch upon other aspects later. So if you see here, what the first satellite that was launched using the Russian help way back in again 1975, that was exactly 50 years ago, April 19th, that event happened. And in fact, this year we celebrated 50 years of Aryabhatta also. Here again, if you see, how did India make use of its actually opportunities that were given? Like I said, Dr. Sarabhai actually brought in a satellite from Americans, but he himself did not live to see the fruits of his work. He passed away early in 1971, but then after that, Professor Satish Dhawan, Professor R. Rao, and a whole lot of them took over and then ran this organization. So the first thing was broadcasting, communication, weather monitoring. These were the things. And bringing sounding rockets in the form of kits, started assembling, launching them, and started working on satellite launch vehicle. Similarly, if you were to build all the capabilities sequentially, that means first you build the rocket, then you build the satellite, then find its application, it would have taken much longer time. So what India did was, when Russians offered, we will put a satellite for you into orbit, so India went ahead, and Udupi Ramachandra Rao, who is also another Kannadiga, was actually in charge of this mission, and within a matter of 3 years, India built a satellite called Aryabhatta, and that was built in the Peenya industrial sheds here. Like the first sounding rocket was assembled in a dilapidated church, this actual Aryabhatta satellite was built in the industrial sheds of Peenya. So starting was in a very humble manner. You have also seen a lot of photographs where people have carried rocket parts on their cycles, etc. But what this showed was, India was alive to every opportunity it has got and to build its capability. So Aryabhatta was built in 1975, and Russians said, we will also give you an opportunity to put 2 more satellites. India started building remote sensing satellites. Now what is a remote sensing satellite? It is a satellite which can look at Earth and collect information remotely, and by picking up this information, find out what is happening on Earth. For example, in the initial period when the government had to be convinced, there was one great professor called Professor Pisharuti. What he had done was, he had borrowed again an infrared camera from an American laboratory, flew it on an aircraft in Kerala, and Kerala, there is a disease for the coconut tree is called root wilt disease. He was able to take pictures from the aircraft in this infrared camera, and doing analysis of that data, he could identify which portions of the cultivation or the coconut plantation the root wilt disease has affected and which has not affected. That means by remotely observing things, you can come out with whole lot of information. That's how space technology started making a difference. So India started building its satellites with the opportunities provided by Russia, and with that as a starting point, it went ahead. Similarly, in the launch vehicle, Europeans were building their first launcher called Ariane. In their first launch, they said, we will give you an opportunity if you want to build a satellite and go ahead. So India took that opportunity and built a satellite called Ariane Passenger Payload Experiment, Apple. So first 3-axis stabilized satellite India started learning by building that. So the point what I am trying to make here is, India started with a very limited resources in 1947 after many hundreds of years of external rule, where the colonial had actually extracted all the resources from here and taken it away and left us at a very, you can say, low level of economic growth. But then starting from that, if you have to build capability, you have to make use of all the opportunities available, and that's what India did. It convinced others of the technology they were building, showcasing them that it can be put to better use, and then went step by step. So what Dr. Sarabhai had done by that time was, actually he had made sure that India was well into the space technology arena. And you will be also very happy to know that India is the only country which started space program for non-military applications. Everybody else had started the program with military purpose in mind. And then India demonstrated, if you want to reach out to the large population that it had got, it has to make use of the satellite instructional television experiment and do the thing. And then for doing weather monitoring, for actually providing early warning for cyclone, etc. And then also it made use of the remote sensing data for a whole lot of application, including identifying where you can drill a bore well. If you drill a bore well, can be assured of getting water. So almost in between the late 70s to 2010, etc., more than 4 lakh bore wells had been drilled across the country using this technological support with more than 90% success rate. Similarly, India started building its own remote sensing satellite, and then using these satellite data, it was possible to tell what is the crop that is growing. For example, today there is a center in Delhi called Mahalanobis Crop Forecasting Center, which is able to tell for 21 crop types what is the yield that's going to be there this year and what can be your export or import provision information it provides to the government, and also provide information to farmers about the soil properties and then what kind of micronutrients it need to be provided to them. Whole lot of these activities are going on using satellite based observation. So India, starting in a very simple manner, went on building. It built its satellite launch vehicle, then polar satellite launch vehicle, then geostationary satellite launch vehicle, then another recent one is a small satellite launch vehicle. So all these vehicles are being built step by step, and then learning this process took also a significant amount of time, because you can visualize the space technology is a technological capability which military powers are looking at how to make use of it for dominance. And then information, by the very nature of its activity, is not something which is easily shared. And then India, starting with these activities, today where it has reached, like I said, we launched this year one of the world's most actually advanced technology satellite called NISR, SweepSAR technology, which provides the entire global coverage every 12 days with a few meter resolution in 2 wavelengths, which can help us understand the surface deformation that happen on the earth, and then even below the earth's surface to some extent, water, ice and biomass, a whole lot of things. More than anything, by systematic repeated observations of this, you can build models which can help you do early warning of many things. It is expected that in future even earthquake precursors can be picked up by this satellite data. And in building all this, as you have seen, we went step by step. The first satellite launch vehicle could carry only 40 kilograms. Then today we have got capability of putting more than 4,000 kilograms into orbit. And even while doing this, many times you face hurdles. For example, you are told that a cryogenic engine which was built in the country, actually initially India wanted to take the engines built by Russians, and a contract was established. But then Americans made sure that this technology transfer did not happen. They twisted their arm, and then India was denied this technology. But then when you are denied a technology, we had enough intellectually capable people who could make use of the limited resources that was accessible to them and build this technological capability. And today we have more than 4 versions of the cryogenic engine which is used in our launch vehicles, which is able to put satellites into orbit. Just to appreciate the complexity of this engine, liquid oxygen and liquid hydrogen, which are there at very low temperatures, not only you need to make sure that the heat leak doesn't evaporate that, but also when it goes into the engine and fires the engine, just for 1 second, if the cooling of the engine is not proper, the entire engine will melt. So you have to not only make sure that you are carrying very low temperature material, but also you bring it back to the requisite gaseous phase and with the pressures and operate and reach temperatures which would melt metals, but then still make sure that it works. So what India has done is, using this capability, it has today launched not only our own satellites, but also satellites of almost 35 other countries. Of more than 500 satellites has been launched by India. This shows that India, while it is building its indigenous capability, is also capable of making use of it for providing solutions to the problems, not exactly problems, providing opportunities for others also. In fact, if you see in this fashion, India is today has made use of its launch vehicle PSLV to go to 500 to 1000 kilometer orbit, 36,000 kilometer lunar orbit, and even 200 plus million kilometer Mars orbit. It's able to take satellites to all these. So before I touch upon the celestial activities, coming back to the basic developments. So India, starting its activity way back in 1963, over a period of time built indigenously launch vehicles, satellites, and more than that, applications of these satellite data for bringing in changes in the lives of the people. Probably many of the young people here, if you ask your parents or grandparents, probably when some new arrival was there in the family, how were they able to communicate with other friends and relatives in the mid 80s or the early or the late 70s? They would tell you that you had to go to a place called Central Telegraph Office, do a call, person-to-person call booking, and on that day, if you are lucky, you will get the connection. Otherwise, you will go back and come another day for doing that. But today, a small gadget in your hand, you are able to instantaneously connect to any part of the world. And how this has happened is also the same space technology, putting satellites into geostationary orbits and low Earth orbits, and through that send signal to the satellite and back to Earth, and almost instantaneously cover the entire globe. And like I said, India also started this activity and demonstrated today by bringing in the INSAT series of satellites, you have got coverage over the country. Not only that, India, true to its traditional wisdom, which says the knowledge and skills you acquire should not be limited to your individual use, but also for the benefit of the society. So what India did was, it built a satellite called SARC satellite. The satellite dedicated for providing transponders to our neighboring countries. So India offered this satellite service free of cost to many of our neighboring countries. In fact, I remember on the day when this satellite launch took place, Honorable Prime Minister had brought all the heads of states of our neighboring countries on a television program on live interaction. On that day, what the Afghan president said will make you feel proud. Afghan president said, "We are all used to people making promises, but it is for the first time I am seeing a promise made which has been fulfilled in real short time." That was a compliment given to India by Afghan president. So in building these technological capabilities, step by step, India started building its skills, and then with the limited resources, and when the first nuclear explosion happened and the second nuclear explosion happened, India was put under ban by many countries, denying many advanced technology components. In fact, many of these restrictions put as a, you can say, a driver, and it gave new impetus to the development in the country. And just beyond 98, India developed one of the advanced technology Earth observation satellite of providing a few meter resolution images, and also that post-Kargil war, India looked at developing its own navigation satellites. That means as India started developing from a very low position in the economic condition, as it started increasing its capacity, it started becoming clear that space is no longer only being used for development purposes, but those who are capable of going to space are going to make use of it for military activities also. But before coming to that, let me also talk about the developments with respect to science and technology itself. India, right from the beginning, wanted to make use of all the opportunities that are available to learn more and more about science. The very first satellite that went up, Aryabhatta, actually carried a host of instruments for looking at X-ray sources and many other such things. So you can see when human beings look at space from ground, atmosphere comes in between. So many times if it is cloudy or even turbulent weather, what you are seeing in space can be affected. But if you can go beyond the Earth's atmosphere, then there is nothing that comes in between the observer and the object, and you can make better observation. So India also started building its capability for doing observations beyond Earth. There were two primary reasons for that. One is, you know that in any area of technology or science, if you want to remain actually competitive, you have to learn newer and newer things, and you have to develop better and better skills. That will happen only when you do more challenging things. Like I said, India built its launch vehicles to put satellites into near Earth orbits, geostationary orbit, which was 36,000 kilometers. But then going beyond that, going to Moon and Mars, etc., why would it be helpful? Because you are building a technological capability of taking objects farther and farther. Your communication capability improves. You are able to build objects which can perform autonomously. And it is with this in mind, India did its first Chandrayaan-1 experiment way back in 2008. And as I had already mentioned, man had landed on the moon and large number of probes had touched the surface of the moon. But still, in Chandrayaan-1, what India demonstrated to the world, you are definitely aware that Chandrayaan, though it was done in 2008, much later, gets the credit for discovering the presence of water molecules on moon, and also the process of water molecule formation was actually recognized, and this finding is attributed to Chandrayaan-1 satellite. So what this shows is, in science and technology area, it is never too late. Though you are much later than others, what you did made a huge change in the way humanity thinks. And in fact, you will also be happy to know that it is that mission which changed the perspective of human beings about moon. Then they saw water is a possibility there, so there was renewed interest, and you have seen in the recent past there are many activities going on where man wants to land on moon and then explore the moon itself for various things. So Chandrayaan-1, when we launched in 2008, one of the objective was to provide more challenging tasks to our own scientists and engineers, and then build this technological capability and use this capability for improving the satellites we are building for other applications on ground. And in Chandrayaan-1, we just orbited around the moon. And in Chandrayaan-2, what we wanted to do was actually land on the surface of the moon. But anyway, before coming to Chandrayaan-2, let me complete Mars story. So again, Chandrayaan-1 is 384,000 kilometers, which is 10 times the distance from 36,000 kilometers, which is the geostationary. And then Mars, if you have to reach, it takes a vehicle to travel much farther and longer. So what was done is in 2013, on 5th of November, from Sriharikota, we launched a satellite. What was the task cut out for this satellite? It should travel a distance of 60 crore kilometers or 600 million kilometers over 10 months period, and at the end of the 10 months period, on a specific day and time to the second, this object should have been inside, you imagine a cube in space of 50 kilometers. So this satellite, after traveling 10 months and 600 million kilometers, on 24th of September 2014, morning 7:30 a.m. to the second, if this satellite were not inside that cube, it would not have been possible for us to make the satellite go around the Mars. But then all this successfully happened. What were the difficulties? You can imagine if you just take a sheet of paper and blow your mouth on that, there is some force generated. Even sunlight falling on the satellite produces what is called radiation pressure, and through radiation pressure a force which can take this satellite away from this cube to the tens of thousands of kilometers. So that means not only should you be tracking this satellite, you should be able to communicate with that satellite. Even at the speed of light, when you are sending a signal, speed of light, as you are aware, is 3 lakh kilometers per second. At that speed, if you send information, it takes, when the object is near Mars, almost 12 minutes when it is closer to Mars for it to reach. You send a command from your system, it takes 12 minutes to reach, it operates, then it sends the signal back saying I have done the job. So it has almost taken 24 minutes or half an hour. So you can imagine the people sitting at the console, how they are feeling. Many times when you turn on your computer, it takes some few hundreds of milliseconds to come up. But then you start feeling fidgety. My system is very slow, I need a faster system, etc. So now you can imagine here, people are waiting almost half an hour before they know what is happening. But point is, you cannot do real-time intervention because it takes long time. So you have to build intelligence into the satellite to not only deal with the problems it faces, but also correct itself. So you have to build in the satellite more and more technological capability, more and more intelligence into that system. That's how progressively you start building more and more intelligent satellite. And today you are talking of machine learning, artificial intelligence, etc. They all become essential for doing that. So when this Mars mission was done again, world started looking at India. How is it that India became in its first country to perform in its maiden attempt a task which others have taken multiple attempts to reach? And then here I'll touch upon this aspect in a later point in time. So world took note of India's development. It had done this with a launch vehicle which was actually only polar satellite launch vehicle. Similarly, the Mars mission itself, if you take, Originally, our plan was this satellite will operate for about 6 months because the amount of fuel we could carry was very limited. And then we were expecting about 6 months of operation. But the entire process had gone so successfully without getting into problems that we could operate the satellite for 8.5 years, doing much more than what we had originally planned. Then coming back to Chandrayaan mission, you saw when we did our Chandrayaan 1, we just discovered water, but our longevity of the satellite in the orbit was limited to only about 10 months. Then Chandrayaan 2 we wanted to do, where we wanted to land on the surface of the moon, put a lander on the surface. But in Chandrayaan 1, we had also carried an object called Moon Impact Probe. In fact, that was actually an idea suggested by President Kalam at that point of time. You carry an object and leave it on the surface of the moon carrying Indian flag. So in Chandrayaan 1, we had released a moon impact probe which went and hit the surface of the moon, and the place where it hit is called Jawahar Sthal, and it was an uncontrolled descent. But that object carried two instruments. One was a camera which was taking pictures, other was actually a mass spectrometer which actually detected presence of water molecules as it came closer and closer to the surface of the moon. But then in science, actually if you want to prove what you have actually discovered, it requires lot of corroborative evidence. So by the time this mass spectrometer data could be convincingly shown, the other instruments which were present demonstrated that what presence of water molecules on the moon, etc. But then in Chandrayaan 2, we wanted to carry a probe which touched the surface of the moon in a controlled manner. So we planned it, and in 2019, when we launched this particular mission, Chandrayaan 2, it had two major components. One was orbiting the moon, and the other was coming out of the orbiter and go and touch down the surface of the moon. Now you can imagine, suppose you are asked, you go and touch down on a place, what is the specific information you would need? Where you are going to touch down, you should collect information, sufficient information about that, so that the object which you are carrying and want to touch down there, you want to make sure that it touches down on a safe area, an area where there are no boulders, no craters. So you need to identify a good safe zone for touchdown. For Chandrayaan 2, when we started, the only data we could get was through some alternate source, and that data had lot of limitation. So we had identified a 500 meter by 500 meter area for touchdown. But in Chandrayaan 2, we were carrying a camera which even today produces highest resolution images of the moon by an orbiter. So using this orbiter, we collected continuously the images of the moon and then used it for Chandrayaan 3. But in Chandrayaan 2, what happened? We were building for the first time a new capability in the lander, where the engine had to be provided a capability of variable thrust. Like when you are going on a scooter or a mobile or even a car, your accelerator, if you press, vehicle moves faster. If you want to slow down, you reduce the decelerate or even put brakes. So till that time, till Chandrayaan 2, we had built rocket engines which once you start operation, it delivers a fixed thrust. Using that we were operating. It means to say, once you start your engine, till the fuel is exhausted, the engine keeps giving fixed thrust. But when you want to touch down on the surface of a celestial object, you need a capability to vary this thrust, because to compensate the forces acting, you need to control it. So for the first time in Chandrayaan 2, we were building an engine which could be what is called throttleable. That means vary its thrust, that capability. So we had built that, and in Chandrayaan 2 we were making the first attempt of this. There were 5 of those engines. We had come very close to touchdown, but at that time certain imbalances in that resulted in us hitting the surface of the moon at a high speed. instead of less than 1 meter per second, it was more than 40 meters per second, which is a very more than 200 to 400 kilometers per hour type of speed. So at that speed it hit the surface, so it disintegrated. But then Chandrayaan 2 we used for our learning experience. Probably many of you would also remember on that day, September day in 2019, we were glued to the television. We came very close, but we failed. But then that failure did not deter India to go ahead and then build a successful mission in 2023. Now what all happened between these two times? Like I said, in Chandrayaan 2, we had identified a 500 meter by 500 meter area. But using our own images of Chandrayaan 2 orbiter, we now found an area which is 2 kilometers by 4 kilometers wide. That means from the starting point when you go and touch down, even if you make an error in reaching that place, you have a safe point of less than 100 meters to touch down. That means you had increased the margin of error in your system. Similarly, between 2019 and 23, using our own ground station here in Bailadu, which is a 30 meter diameter antenna, which is receiving signals from this, we had built enough capability to know about the position of the satellite very accurately. We knew the starting point, we knew the end point. And not only that, we had built features into the satellite for testing all the features of that particular system by operating in orbit and verifying its performance before actually doing it. So these we call as calibrating experiments. And we built all these features, and because of that, on August 23rd, actually of 2023, when India succeeded in landing Chandrayaan Vikram lander on the moon, not only the entire country, but also the globe took note of what India had achieved, because you also remember very close to that event, even Russia wanted to do something in between. It tried, but it did not succeed. And even around that time, many American and even Japanese missions did not successfully touch down that surface. And why that region was very important is because on moon there are areas which are permanently shadowed. That means sunlight never falls on that region. So because of that, water, ice, etc. can form, and South Pole is one such place, and India wanted to touch down there. It was not easy to do, but then because it is difficult and because you achieve, you get global recognition. Equatorial belt, you can find large flat areas where you don't have to worry about craters or boulders, etc. But then these areas are difficult. So when India demonstrated on August 23rd this particular thing, lander came, touchdown, rover came out of it, a large number of experiments were conducted, and it showed India that there are many interesting things happening. A lot of this data is also available in the data center in what is called as ISSDC, International Space Science Data Center, which you can actually use for research. In fact, today there are many research students who are looking at the data collected from our moon missions, Mars mission. Not only that, I would like to touch upon two more satellites. One is Aditya, another is AstroSat. AstroSat is a satellite which is actually looking at the celestial bodies and then collecting information in a specific wavelength. In fact, you will be happy to know that this particular payload is able to provide data in a wavelength region with a sensitivity which no other satellite, even currently operating James Webb, etc., is able to provide. So AstroSat is again a satellite built fully indigenously with Indian Institute of Astrophysics, Tata Institute of Fundamental Research, people working on that and making this capability. Similarly, Aditya is another satellite which is put into a place called Lagrange point. Between Earth and Sun, there are many points where you can place an object and that object can be retained there, placed there without too much of energy consumption. So these are called Lagrange points, and India was successful in putting a satellite there, and you can do 24/7 equivalent of total solar eclipse and conduct experiments on that. So in a way, if you see, India started its activity way back in the 63, and then step by step it started learning, and today where it stands, not only it has built a whole lot of capability for providing solutions to the civilian issues of remote sensing, earth monitoring, communication, broadcasting, navigation, and by the time we also moved up the economic ladder, and today we have very friendly neighbors who give you sufficient freedom to do what you want. So deal with that situation. You should also be prepared for looking at what is happening around you, and these satellites which orbit Earth gives you that capability. Without the explicit permission of anybody, you can look at what is happening across the globe. So India is in a way forced to make use of its capability of space to provide its strategic importance. And then you also saw very recently how in a particular situation your preparedness for conducting the events is greatly benefited by your eyes in the sky. Not only eyes, communication, broadcasting, navigation, all that. So India over a period of time, with the limited resources it had, but with the tremendous intellectual capability, it went on building resources and went on building technological capability, which is recognized globally, and India is among the few countries in the world today which has this end-to-end capability. And then what it is now heading to do is, space has already become the fourth frontier, which means humans, after conquering land, ocean, airspace, is now in the process of conquering space itself. Space tourism, space adventure, space exploitation, space habitation, all of that. What India is planning to do is put humans around the Earth by using its own Gaganyaan program, and then build its own Antariksh station by 2035, and then land humans on moon and bring them back safely by 2040. And in doing all this, doing it indigenously, and not only within the government sector, but also in the private sector, and government has tweaked its policies and has provided many mechanisms like InSpace, etc., to support both academic, industry and others to participate in the area of space and move ahead. So if you look at this journey where a new technological capability became available to humanity, using that capability step by step with limited resources, India built, and today it's among the few countries in the world which has this end-to-end capability. So you are all in a way on the threshold of making use of this technological capability and move further. And if you look at it, then the opportunity next 20 years, what is there in the target for space is already spelled out. Not only improving the capability to use our observation from space for improving life on Earth, but also ensuring that you are among the equals in the world, you are one among the equals competing, and then be an important player in the global arena. And if that has to happen, people recognize you only for your demonstrated capability. Like I said, in 75 when India borrowed a satellite from America, Americans for a long time were never ready to do any common mission with us until we demonstrated Chandrayaan-1 and our own radars. After that, they were ready to work with us for a common mission, this was an event which is almost 1.5 decades of effort, but recently you saw come to fusion, where the actual demonstration of India's capability to be an equal player in space has been done. And then you are on the threshold of this. What awaits you is a great opportunity to move India ahead. Anyway, I'll go through some question answer session before completion. I'll stop here my information which I wanted to tell you about this Space Day, how India actually acquired this skill of operating in space, starting from a very simple background, and then over a period of time effectively building this capability, not tethered by its failures, but then making sure with every failure you go with a renewed rigor and then succeed. Thank you very much. I am open to questions.